Good morning to everyone. I am Dr. S. Sarumathi, Professor, Department of IT, K.S. Rangasamy College of Technology. Today we are going to discuss about data models for online analytical processing and then OLAP operations on multi-dimensional data. Before that, we will see what is data warehouse. A data warehouse is a subject-oriented, integrated, time-variant and non-volatile collection of data in support of management's decision-making process. In general, data warehouse is a repository which stores information under a unified schema. So now let us see what is subject-oriented. It is organized around major subjects such as customer, product and then sales. And it is constructed by integrating multiple heterogeneous data sources such as relational databases, flat files and online transaction records. Time variant data warehouse usually provides information from a historical perspective, and it stores past 5 to 10 years of historical data, and also it is non-volatile. The information stored in a data warehouse are permanent. Now let us see the models in data warehouse. We have three categories: star schema, snowflake schema and then fact constellation schema. The first one is star schema. The most common modeling paradigm is the star schema, in which the data warehouse contains a large central fact table containing the bulk of the data with no redundancy, and a set of smaller attendant tables, that is dimension tables, one for each dimension. The schema graph resembles a starburst with the dimension tables displayed in a radial pattern around the central fact table. So it is called a star schema. The snowflake schema is a variant of the star schema model where some dimension tables are normalized, thereby further splitting the data into additional tables. The resulting schema graph forms a shape similar to a snowflake. The major difference between the star schema and snowflake schema is that the dimension tables of the snowflake model may be kept in normalized form to reduce redundancies. The third one is fact constellation schema. Sophisticated applications may require multiple fact tables to share dimension tables. In that cases, we have used galaxy schema or fact constellation schema. The fact tables are shared by dimension tables. So this is diagrammatic representation of star schema. We have sales fact table which contains the primary key of all the dimension tables. Here time, item, location and then branch are dimension tables which contains attributes, and the first attribute acts as a primary key for that particular dimension. So here we have time key, item key, branch key and then location key, and we have three measures: units sold, dollars sold and then average sales. So these are all the measures, and then time key, item key, branch key, location key are the primary key of respective dimension tables. So the fact table is a combination of keys of all the dimension tables along with the measures. Now let us see how to define star schema using data mining query language. For defining the sales data warehouse, we have defined cube, sales, star. That is the name of the star schema model. And then we have four dimensions, namely time, item, branch and then location, followed by set of measures used in a fact table. So define cube are keywords here. Sales star indicates this model is under star schema, and the data warehouse is sales. So we have defined cube, sales, star and then time, item, branch, location, followed by three measures we have used: sales in dollars, average sales, and then units sold. Followed by we have to define the dimension tables in sales data warehouse. So for that we are using define dimension time as time key, day, day of week, month, quarter, year. Here we are having attributes time key, day, day of week, month, quarter, year. So and the dimension name is time. So we are having define dimension time as time key, day, day of week, month, quarter, and year. So respectively we are defining item, branch, and then location dimensions.